This is lesson 12.4, part 2. Okay, continuing on, we are going to use standard deviation and other measures of variability, and along with the measures of central tendency, to compare data sets. So one thing specifically we're going to talk about is comparing, or what types of things that we use to compare, what types of measures we use to compare if you have different types of data. So specifically, symmetrical versus non-symmetrical. So if both sets of data are symmetrical, like what we see in this box and whisker plot, or if we saw a dot plot that appeared symmetric, like on the first part of the lesson, then we would use the mean and the standard deviation. Those would be more accurate representations or ways to compare the data. If one of the sets or both of the sets are not symmetrical, then we would use the medians and the interquartile ranges. That would give us a more accurate picture of how these looked. So just to look at how we're going to do this and why one makes more sense, let's go ahead with Mrs. Johnson gave a test to 24 students in each of her math classes. The results are shown below. So we've got A1 and we've got A2. So we're going to create a dot plot for each class. So go ahead and pause the video. You're going to make a dot plot for each class A1 and A2, and then we're going to pick up and we're going to start talking about how to compare the classes. Okay, so I've made dot plots for both classes, and you should have done that as well. So a couple of things that we noticed before we get into what we're going to compare. If you notice on both of them, they both look like they would be symmetric. One question you might have is about this 37 that's out there. That could be an outlier. We're not going to worry about that being an outlier because we're still going to have to compare like the medians and the means or the standard deviations or whatever, and either way we're still going to be counting that outlier when we do those measurements. So it doesn't really matter if it's an outlier or not. With a dot plot, you're just going to put it there. So because these are symmetric, according to what we just read up here, if they're symmetric, we're going to use the means and the standard deviations to compare the data. And that's because they resemble more of a normal curve. And so a normal curve is going to use a mean and standard deviation to describe the symmetry and how much they're varying. That's going to give us a better picture. If we were looking at non-symmetric data, or if one of them was non-symmetric, and remember, we're not looking for perfection. When we talk about symmetry, we're not looking for it to be perfectly symmetric. But if one of them was very definitely not symmetric, then we would be looking at the median and the interquartile range. So maybe like more of a box and whisker plot would be like maybe a better way. So the question, are both sets of data symmetrical? I would say yes. Again, we're not looking for perfection, but generally like A1 is actually perfectly symmetrical. A2 not so much, but it is bulky in the middle and it comes down on either side. So that's why I would say that that is symmetric. So we're going to compare the mean and the standard deviation. So in order to do that, we need to find the mean and the standard deviation for both classes. So pause the video again. You're going to go in and you're going to find the mean for A1 and the standard deviation for A1. And then you're going to do the same thing for A2. Okay, so if we're in class, I'm going to have half the class find one of these and half the class find another. If you're watching the video on your own, you're going to need to use your calculator to find the standard deviation and the mean for each one of the classes. So go ahead and pause and do whichever part you need to do. Okay, you should have gotten these numbers. I did round. So A1, the mean came out to exactly 28, and then the standard deviation I rounded to 2.5. A2, the mean came out to be approximately 28.4, and the standard deviation 2.2. So what this says is it says that the mean on both of these classes is really very close to being the same. And if you look at both classes, the middle of each of them is right there at 28. That's where the obvious middle is. That's where the peak of my curve is. So that makes sense. The thing that it says with the standard deviation is it says that A1 is more spread out than A2 is. And if you look at the graphs for that, it is very obvious that A1 is more spread out than A2 is. And so that's what we're looking at as far as the symmetry and what each of these pieces mean. And so as far as comparing, we need to write a sentence about that. So you can say something along the lines of, although both classes average about the same, A1 is more spread out or more varied than A2 would be. So say something like that. Make sure you do some type of comparison using both measures of central tendency and variability. Okay, the next one we're going to do, we're going to make a box and whisker plot for each set of data. Label the extremes and the quartiles, so we want to make sure we can read this. So I've got the area of western states in thousands of square miles and the area of midwestern states in thousands of square miles. So you're going to make two box and whisker plots using this number line. So you'll make, one box up there, one box over there, however that goes, and make them over the number line so that you can read what they are. So go ahead and pause, come back when you're done with the boxes, or the box and whisker plot, and if you have any questions, I hopefully will answer them in the next part of the video. Okay, I have my box and whisker plots here. For both, since I had the same number of data in each set, I just split the table to find the medians and the lower and upper quartiles. You do have to approximate on your number line where things are, and that's why I have the numbers on each part of the box and whisker plot. Now, one thing you probably notice is that this state, this is Alaska, it is a lot bigger than any of the other states. So even if you take California, multiply that by like 5 times, that's how big Alaska is. Alaska, even without doing actual calculations, that's an outlier. So that's why that's represented on my box and whisker plot as an asterisk. It's all the way out there. In fact, I couldn't, stretch my paper out to go further. So it would actually be a lot more out there. If I wouldn't have listed that as an outlier, I'm going to have this whisker that's just going on and on and on and on. So that's why we're going to list that as an outlier. I'm still going to count Alaska when I calculate mean or when I calculate range or whatever. So that does mean that the western states vary a lot, because between 71.3 thousand and 656.4 thousand, that's a huge range, way bigger than the other states. So in looking at those, the next question we need to ask ourselves, are these both symmetric? So if you look at the western states, I would say probably not symmetric, but if you throw in, considering this outlier, definitely not symmetric, because this whisker on the right is so long. I would say probably not. If this wasn't part of it, then I would say probably not. Just this is a little bit longer, and this side of the box is a little bit bigger. So I'd kind of lean towards not symmetric. The blue box looks more symmetric except for that line inside the box. So I'm going to go with these are not being symmetric. There's just too many what ifs out there, and so I just don't think that I would feel comfortable saying that these were symmetric. So what I'm going to be comparing, if they're symmetric, you're going to be comparing the median and the interquartile range. So the median is the middle part of the data, so where half of the numbers are bigger and half the numbers are smaller. Also, since I'm comparing the interquartile range, it's talking about the mid 50%. So Alaska is not really going to sway any information there, because I'm talking about just the middle 50%. And so when I compare that, I can see that the western states, let's write this down. So the western states, the median is 107.35, and for the midwestern states, the median is much smaller, and that is at 70.2. Now this is in thousands of square miles, so that's 70,200 square miles. And then if I look at the range for each of these, the range, the interquartile range, I should say, interquartile range, is from the third quartile to the first quartile. So how far is that? So 134.3 minus 91.35. Okay, so I've written here my interquartile range. So if you look at this, if you look at the western states, they're a lot bigger than the midwestern states. So the western states, the top 50% are bigger than all of the midwestern states. And so that's a really big distinction. The top 75% are bigger than almost all the Midwestern states. So you're really looking at the Western states being a lot bigger. Not only that, but there's much more variety in the sizes. So if you look at, how big the spread is, this is really tight in there, this is more spread out. That means there's more variety and more variation in the size of the states. So I'm going to say that the Western states are a lot bigger. And then also that they vary more in size. When you're talking about either interquartile range or standard deviation, you're talking about a measure of variability. So you want to use the word vary or varies or variation or something like that to kind of indicate that that's what you're talking about. Okay, so just say something along the lines of that. So when you're asked to compare, make sure you're comparing both measures, so you say something about them, both indicators there. So that's what you would write. Okay, for your test, which is next time, these things are things that you need to be able to do. You need to be able to find your measures of central tendency, so that's the mean, median, and mode, and the measures of variability. That's the range, the interquartile range, and standard deviation. Okay, what I mean by being able to find these with and without calculator stats, I mean without using your standard deviation key or your statistics key on your calculator. So in other words, to find the mean, you need to know that you add up all the numbers and divide by however many data points you have. You need to know how to find the median, put them in order, find the middle number. You need to know how to find the mode, how to find the range, the interquartile range, without anything fancy on your calculator. However, I will not make you find standard deviation without your calculator functions in that area. You need to be able to make and read two-way tables, dot plots, histograms, bar graphs, and box and whisker plots. Know when you do histograms and when you do bar graphs. That's what I say in the next one. Know when you would use each one. Know how to find the quartiles and what they represent. So meaning the lower 25%, the upper 50%. How do you find the quartiles? Know the percentages for normal distribution. So that's the 68%, the 95%, and the 99.7%. How it relates to the mean and the standard deviation. So that in a normal curve, you've got the mean as the center line, and then you've got one standard deviation on either side, and then 2, and then 3. Know how to tell if data is symmetrical or not. So basically, when you look at a dot plot, or you look at a histogram, or you look at a box and whisker plot, can you tell if it's symmetrical? I'm only going to ask you things that are obvious. It's not going to be something like, well, it could be either one. So anyway, and how it affects what you would use to compare data. So remember, if it's symmetrical, you're going to use, like the normal curve distribution, you're going to use the mean and the standard deviation. If it's not symmetrical, you're going to use the median and the interquartile range. Know what skewed left and skewed right means. So the things that you've seen in all of your quizzes for this, those are going to be on your test. For this test, I do have a practice test that you need to do. I will allow you to take it a couple of times, and I'll keep your highest score, but these are the kind of questions that you're going to see, and so you want to practice with that. If you don't get this test done by the time the cutoff date for it is, then you will not be allowed to take the practice test.